This is a short video showing a queue structure, and I call this an Ouroboros queue because it's like the serpent that is eating its tail, and you'll see why in a minute. So this is actually a circular single-linked queue structure. First, for beginners, this will show you how to use linked list structures effectively, and some detail so you can learn about linked structures. So a queue is like a line in a club. So the first in the line gets into the club first, and the last one is last into the club. So we're going to teach beginning students more about linked structures going through this. So this is a picture of the structure here, and it uses a circular linked list. Now, a circular linked list is where you have nodes that hold data, and in this case the data can be strings or numbers in Python. In the C implementation I show, I just have numbers, but it's something that you want to queue up, and the order of the queue is organized so that you have a rear and a front, and Amy is the last person in this queue, so that she's in the rear, and Bob happens to be at the front of the queue. And there's an external pointer that's going to be kept, which will be called rear, that points to the last node in the queue line. So the queue line runs this way, and there's a pointer from each node that points to the next person in the line, starting at the head of the line. So the head of the line, Bob, who got in line first, would be the first person out of the line, and then Sam would be the next person in priority to get out of the line, and so on. So the arrows point backwards until they eventually arrive at the tail of the queue, which is Amy, which is the last person to get in line, and then Amy points to Bob. So to do this, we're going to build a queue class in Python and a node class. So the node class will hold the individual nodes, which are these box things, which hold a piece of data and hold a link which points to the next node. So this is what this points out here. Now the queue class is going to have one field called the rear field, and that's represented here. So that will just point to the last node in the line, or the rear of the line. So we're going to have two methods in the queue class to use the queue, and these are traditionally called enqueue and dequeue for queues. Enqueue, you pass one parameter and you invoke it on the object that's a queue object, and it's going to add the data D to the queue. And then you have dequeue, so you call the queue dequeue, and this removes the node at the head and then returns its data. So in this case, the head would be Bob. It would return to string Bob, and then Bob would be removed from this circular linked list, in which case the list would be modified, and Amy would now point over to Sam as being the new head of the list. So let's walk through how this works in Python code. Now this is going to be optimized Python code, and the code we show you online is going to be refactored to make it a little more efficient. So here's the node class. It has two fields, the data field and a link field. So here we define a node in Python, and then in the constructor we take no data as parameters, but we set the data to none and the link to none. So it starts off making an empty node with no data or no link. And then we have the queue class, which has one field, which is the rear. So this is a little diagram of these two. We can easily do this not using classes or using classes. And in the C version, for example, we're not going to use classes. There's no classes in C. So we're going to be adding other languages as we go to our example site. But right now you can look at both a C example and a Python example. So let's look at how enqueue actually works. So enqueue passes some data. Now whenever you do linked structures, or in a lot of times programming, you have to consider special cases. So there's a special case if the queue is empty. We have to do a little different code than there's already nodes in the queue. So this is in the case where we have an empty queue and we want to add one node. So we call enqueue on the data. So here we're we create a queue, so that stores the new queue object in queue, and then we enqueue one into that queue. So this shows the before and after, and you can see the points in time here in these comments of where I'm showing these diagrams. So this is how you follow this. So in enqueue, if the rear is none, meaning we have nothing in the queue, is what that's going to mean. That's how we test for it. Then we set in to a new node, and then we set the data into the node. So node.data, and we store the data. And then we set the link pointing to the new node, so the link is going to point to itself. And then we set rear to point to this new node. So when we're all done, rear will point to the new node, and the node points to itself. Now I use red here to indicate all the things we had to change. So we had to create the node with the data value, and we had to change the link that rear was pointing to and the link that link was pointing to. So you can see here we changed the data for the node. Here we create the node. Here we change the link for the node, and here we change rear. So these red indicate each step we have to do in our data. Okay, so now let's go to the general case where we're actually adding a queue to we're adding a node to a queue that already has nodes. So here is before we have one or more nodes. So here's the structure. We have the rear here. Rear points to this node, and this node then points to the front, and in which case there's a chain and it eventually points to the rear. So to add something, we're going to add it to the rear. So we want to end up with this. We want to end up with the old rear will now point to the new thing that's added to the end of the line. Rear will be updated to point to that new node with its new data, and the link for that node will point back around to the head. So to do that, again, these red, and this is when you're developing linked list code, you can write down a before and after diagram and look at everything that's changed between these two diagrams, which are the red pointers, and that's what you have to do in your code. So first, if the rear is not none, that would be detecting that it's not an empty queue. Then we would create a new node. We would set the data for the node. We would set the link to the node to point to what the rear link before pointed to. So what was the rear link before? The rear pointed to this, and its link pointed to the front. So this is actually getting the link to the front and storing that into the new node. So the new node points to the front. So that's that part. And then the self rear link, so that's the front, is pointing to the new node. So what's this talking about? Well, this too was the old rear. We have to change the old rear's link to point to the new node. So we have the rear's link points to the new node now, instead of to what it used to do, which was the old head. And finally, we set the rear to point to the new node. So rear now points to the node with 3 in it. So this shows you the code that leads up to this. And at this point in time, A, this is how things look. And at point B, this is how it looks. And then we have DQ. And since we've been looking at this in detail, I put all the cases on one. So we have the case of an empty queue. What do you want to do when you try to remove data from an empty queue? And I decided in Python to just return none. So we check if the rear is none, return none. Else, we have one or more links, and we always do the same thing. So basically, we're going to remove the head. It's going to go away. It's grayed out here. And we're going to change the rear link to the new head. So you see there's only one thing in red that we have to change. So if there's one or more, first we get the node that the rear points to. So what is the link from the rear? The link from the rear points to the head. So we're actually getting what's this one here. And we're saving that node. Now if n points to the same thing as self rear, that means we only have one node, and this happens to be a special case. We just set rear to none. Else, in the general case, we set the rear link, which is the rear link to 3. We're going to change its link here to point to what this node link. So remember, node is the front, so the front points to 2. So when we change in link and store that into the rear link, it's going to change the new rear to point to 2. And that's it. So you can get the code, and it's been refactored to make it more efficient. So I've taken out redundancy. I've added a constructor with parameters for node, and you can look at the changes I've made, and I'll show that in a second. And so, but here's a place you can go: github.com, Gerry Jenkins LB, Ouroboros Q, and if you go to there, you'll see the code in Python and C. And the file for Python is q.py. In fact, let's go there and look at the code. So here's the code, and you can see here's the Q class, and let's scroll up. So here's the node class here, and here's the Q class, and here's our code in here. And we've added one extra thing here as an iterator, which you can read about in Python. But an iterator allows us to loop over all the items, and it returns them so we can easily make a list of them. And so, and you can look at how this works. But this is a little bit more advanced Python. And then we have some testing code here that just encodes some things and prints out what's in the queue using this iterator. And then it takes some things off the queue and prints that out, so you can see how it works. And lastly, here is the GitHub repository. So I have the original slideshow here. I have the queue for Python and a queue for C. Please subscribe to my channel. You'll see an icon in the lower right to do that, and you'll receive notifications when I post new videos. Thank you.